Good afternoon to all of you. And today we'll start a new chapter. And hope all of you have done the assignment. And deadline was given. Hope all of you are having answer and you might have written. And you can submit both the assignments at a time, and don't submit one today, tomorrow, like that. So together you have to submit, and hope most of you have done it. When I saw 1 hour back, more than 20 students, they have submitted already the assignment. Remaining students, I hope they will do it today only. You can take even after 5 o'clock, also after the class you can submit. No problem, today you try to submit it. Let me go to today's topic, Unit 5, SciPy. So in this we are going to talk about integration, differentiation, and another important point is interpolation. So only the content is very small, so it will not take much of time, but if you want to go in deep, even a few hours is not enough. So just we are going to touch how the integration can be done, which function is available in the Python to do the integration, and siren is ringing. Just I'll take a few seconds. Okay, in this chapter we are concentrating on these 3 points. One is the integration, which function is available in the Python, how a differentiation can be done in the Python, and interpolation. These are the 3 things what we are going to study in this particular unit. SciPy is a library of Python models for scientific computing that provides more specific functionality than a generic data structures and mathematical algorithms of a Numpy. We already have a Numpy. Many times we get confused. What is this Numpy? What is this SciPy? What is the difference? Why we use SciPy? When to use Numpy? When to use SciPy? Many questions will come in your mind. What this SciPy contains? It contains so many modules. Optimization, integration, interpolation, image manipulation, all these related models will be available in your SciPy. And many algorithms are there in the SciPy which you can use for your programming. You have 1 minute, either read it twice, thrice, or note down 1 or 2 points from this particular slide. SciPy is a library of a Python model for scientific computing that provides a more specific functionality than the generic data structures and mathematical algorithms of Numpy. You can understand where is a Numpy, what is a SciPy, what is the difference. By reading this twice, you will come to know. It contains models. Which models? Optimization, integration, interpolation, and image manipulation. Many are there. Just to say a few, we have listed. And many algorithms are available in the SciPy. A few things, just like a headlines, we'll see some of the things. With SciPy itself will take us several hours to discuss. We'll wait for another 2-3 seconds. Let me go to the next now. Also, like Numpy and Python itself, SciPy is also free software. No need to purchase or no need to take it from somewhere. So it is like a Numpy, how we import, how we use Numpy. Similarly, we can use a SciPy also. There is one point which you have to remember. Anyway, we are going to make use of SciPy. We are going to import some of the modules and we are going to execute some of the programs in using online simulator only. Throughout this semester, whatever the programs I executed, all we have executed in the online simulator without installation. We tried, and almost 99.99 programs I could able to execute in the online simulator. What is the Numpy versus SciPy, sir? I'm getting a little confusion. No problem, just read it, you'll come to know. Numpy is written in C and used for mathematical and numerical calculation. What is that? Numpy. And Numpy is the most useful library for data science. Nowadays, a lot of trend is there, data science. To perform basic calculations, we use a Numpy. Numpy contains nothing but an array data type which perform the most basic operations. Most basic operations like sorting, shaping, indexing, etc., etc. All these are available in the Numpy. Then what is there in the SciPy, sir? That we'll see in the next slide. Now take a minute, read it twice, or note down 1 or 2 points. For all mathematical and numerical calculation, we are going to make use of Numpy, and a library for data science. To perform basic calculation, we use a Numpy. Numpy contains array data type which performs most of the basic operation such as sorting, shaping, indexing, etc. So this is about a Numpy. Then we will see the SciPy. So that you will come to know the Numpy and SciPy. When Numpy only has discussed so many hours, definitely SciPy can be discussed few more hours extra compared to the Numpy, but it is difficult to do that. Whatever is there in the syllabus, that much only we will discuss, and will try to complete the portion. Now let us go to the SciPy. What is that SciPy, sir? SciPy is built in top of the Numpy. SciPy is a fully featured version of a linear algebra, and most new data science features are available in the SciPy, which are not at all available in the Numpy. We can say SciPy is built on the top of the Numpy. It's above Numpy. So a lot of new data science features are available in the SciPy, which are not at all available in the Numpy. So that's the reason we go for SciPy, scientific. It's a numerical, and fully featured version of linear algebra is available in the SciPy. You may get a same function. Some function is performing some task in the Numpy. The same function may be performed using some other function in the SciPy. Those we are going to witness in this particular chapter. Just go through twice or thrice. SciPy is on the top of the Numpy. A SciPy is a fully featured version of a linear algebra, while Numpy contains only a few features, not all. And most new data science features are available in the SciPy, which are not there in the Numpy. There is a basic difference between the Numpy and SciPy. So let us go to the next. Many sub packages are there in the SciPy. We are not at all going to discuss most of them. Only we are going to discuss a few. For example, SciPy constants, a few constants we are going to see. And maybe integration, interpolation, a little bit we are going to see in this particular chapter. You don't need to copy down, just go through what are the sub packages are there in the SciPy and what they perform, or what is the purpose of those. Linear algebra, even linear algebra itself is a big subject. Even our PG students, they study linear algebra. A lot of functions will be available in that sub package. And even for IO, all we are not going to discuss in our syllabus, but one should know as sub packages in that are available, so that whichever you want, that you can make use of that for your programming. Let me go to the Next slide, if you have read twice, thrice, it is enough. Even Fourier transform, you have studied. You are in 5th semester, maybe studying in DSP now. Hope you people are studying DSP this semester. I think DSP was there, yes. Fourier transform, you might have studied. Let me know who will say a difference between the analog signal, a digital signal, and a discrete signal. Usually in ITC first day we ask this question. Okay, Jyoti is typing analog signals are continuous. Akshita Reddy is typing. Yes, Akshita Reddy, what you told is correct. But I want a difference between all the three. Then what is the digital, discrete, analog? A difference between all the three. Let me know who will type in the chat box within a minute. And I hope I have clarified the difference between the analog, digital and discrete. And Anusha has typed a very nice answer. And even Shiva has also given the little answer. Let us go to the next sub packages available in the SciPy. We have many other sub packages. Just go through. You have 1 minute. We may not go through all these sub packages and their use and where to use, etc. And even SciPy.signal is available for signal processing. And for statistics, we have a SciPy.stats. Many sub packages are available, and we are going to touch hardly 2-3. That's all. Take another 30 seconds. We'll try to see SciPy some sub packages. Let me wait for another 10 seconds and we'll go to the next slide. Okay, let me go to the next slide. The spatial package also supplies a large number of algorithms for calculating the functions that appear in science, mathematical analysis and engineering. Just read it once. So I don't want to click. Instead of clicking, because I'm sharing the window, let me show you the snapshot of these things. What are the different algorithms are there? Those I will show you. So these are the algorithms. A few algorithms are listed. Just go through. Algorithms. These, if I take, that itself will take several hours. Error function, gamma beta functions, and many Bessel functions, elliptical functions. Many are there. So those things will not go in depth. But remember, algorithms are available. That's all. At least names, few names you should remember. So because they may ask a general question as SciPy, features, explain, packages, explain, subpackages, explain. At least you should know a few points to write. Theory questions you practice, general questions. Let me go to the next. The useful SciPy constant package provides the internationally agreed standard values and uncertainties for a physical constant. SciPy contains 2010 code data internationally recommended values of many physical constant. Read it twice. This I'll show you a sample. What are those values? I'll show you a few samples. If you want all, it is also available in one of the link. That link also I will show you. But a snapshot from that link I am sharing in the slides. Otherwise I have to share the screen, I have to click that link and I have to show you all the values. Instead of that, a snapshot I'll show you. Remember, SciPy contains the internationally recommended values of many physical constants, such as a few will see it. Let me go to the next slide. Yeah, in the book they have mentioned a few. Just go through. Atomic mass constant, like that they are given. Another few seconds, just I'll show you, and big list is there for a physical constant. A few are given in the textbook. The same thing I'm showing to you people. Like that we have many. So this is a link. Just if you click a constants you will get. Actually I wanted to show that, but instead of that clicking, thought of taking a snapshot from that particular link, whatever I am getting, just I am showing you in the slides. See, these are the sample. Hope most of you are remembering speed of the light in the vacuum, speed of the light, as well as Newton constant of gravitation. These things you have studied in your previous semester. Anybody can type speed of the light if you are remembering. Nobody is remembering. Gravitation, it was shown to you people in the previous slide. Or still, if you are remembering from previous semester also, you can type a speed of the light or a gravitation. Thank you, Arfali. He's writing a 3 lakh kilometer per second. Thank you, Arfali. Yeah, Aishwarya Inamda, 3 into 10 raised to 8. Thank you. Shiva, Jyoti, and Suraj Sheth, Mohan DK. After a long time, I'm seeing this particular name, Mohan. Okay, Ganesh. Yeah, 9.8 meters per. Yeah, it's correct, Ganesh. Thank you for all your answers. Nidhi Hukkeri and Vandana. Okay, some names I'm seeing after some gap. Okay. See here, many are there. Atomic mass constant, atomic mass constant, energy equivalent, etc. etc. Sindhu, BV, Mariam, Naina, Ashok. Many have typed the answer. Like that, A, B, C, D, E, F, G, H. Like that, big list is there in that particular link. Those who are interested, they can just glance once. You cannot copy, you cannot remember. But see here. Just is like this A, B, C, D, E, F, G, H, I, J, K. Like that it is there. Big list is there. A few I am showing you how these constants are available. Many are there. Just a few snapshots I am showing you people. Say neutron mass. Like that A, B, C, D, F, G, H. Now I took a few samples from N, O, P, Q, R, S. Like that. Then up to Z or W, whatever is there. Up to that character, all these constants are available in this. Let me go to the next. Yeah, even all of you know the kilo means what, in SI, giga means what, tera means what, peta means what. See, up to 10 raised to 21, 24. These names you try to remember. This is when you increase 10 raised to. Most of the time we stop here, a giga, maximum tera. We don't know about that. Let's go through that. Similarly, lower side, milli, micro, nano, pico. Like that we have fem2, like that it is there. At least these things you try to remember. Similarly, week and number of seconds in a minute, hour, day, week, etc. And foot means how many meters. Those things also we are going to see. A lot of these things are available in the constants. So let me go to the next. Yeah, now a small program how to make use of these things. Let me ask you, 1 kilobyte means how many bytes? Answer may be wrong, no problem. Type your answer in the chat box. 1 KB means how many bytes? Arfali, thank you for your answer. Right or wrong, we'll see it. First, I thank you for your answer. Shiva, Naina, that's a difference. Hrishikesh thinking is different. And Aditi, Jnanashri, good. Goprepa, after a long gap, he's typing answer, good. Lakshmi Priya, Surat. See, 1000, some people they are typing, some students are typing 1024. Which one is correct? Somebody has to type with confidence. Sir, this is correct. Mohan, DK, Ganesh, Akshada, Arfali is typing. Yes, 1024 is correct. Most of them, they are typing with confidence. I like these students. I'm very happy to see. And 1 MB means similarly, okay. You may need a calculator. I don't know how you people are going to say. 1 MB means, yeah, Rishikesh has used the common sense, and 1024 KB, yeah. And 1 gram means how many kg? 1 gram. 1 MB is 1024 KB. Nidhi Hukkeri is correct. 1 hour means how many seconds? Anybody? Yeah, Shiva has typed, and Rishikesh has typed. 3600. Sanju has typed something. 3600 seconds. Okay, we'll check it. 3600. Majority are typing 0.01. Bibi Mariam is typing. Rohan, Akshay, Akshay. Oh, 2 Akshay are there. Huh? Good. And Nidhi Hukkeri, 1 gram means these many kg, 0.01. Good. So how we make use of these constants, I'm going to show you. The simplest how we can use it. From SciPy, thank you Jyoti, import constants, Nidhi Hukkeri is typing, print constants dot. Those you can simply write down whatever you want, the constants. KB, megabytes, gigabytes, gram, degree, minute, hour, day. In the comment we have mentioned what should be the answer. The same answer we got. Take a 1 minute and just go through how to make use of these constants. Take another 30 seconds, just go through how to make use of these constants, when how to access as a part of program, how to write. Just go through and try to remember. Let me go to the next. Hoping most of you completed. Now, definite integral of a single variable we are going to discuss now. The SciPy integrate package contains a function for computing a definite integrals. What we use, the name of that integration routine is a quad. SciPy.integrate quad. In its simplest form, it takes 3 arguments. What are those, sir? How to do, sir? That one example we are going to see later. Just read it once. You have a more than 1 minute time. Go through and copy down one line at least. The basic numerical integration routine is SciPy.integrate.quad. And its simplest form, it takes the 3 arguments. In simple usage, lambda expressions are convenient way to define function. How to do, sir? With example, we are going to see in the later slides. Okay, hope most of you have copied from this slide a few points. We'll see an example. So, simplest example, to evaluate an integration ranges from 1 to 4, x raised to minus 2 dx equal to 3 by 4, what we get. But how to write in the Python this, from SciPy dot integrate import quad, and this x raised to minus 2 is nothing but 1 by x square. So I am writing function equal to lambda x colon 1 by x square, whatever the function is there, that I will write for the f, and print, then I will use a quad, whatever I imported, integration. And for these three parameters I have to pass. What are those? One is a function, another two are the limits. From 1 to 4 limit is there, therefore I am passing 1 and 4, and another is the name of the function, and this is the integration, therefore quad I am calling. So copy down all these three lines, try to understand. Usually you will get an answer 0.75 something, and some estimate of a absolute error will also come, but this is actually a result. What might be the maximum error, that also you will get. Answer will be like a tuple. Take more than 1 minute, copy down the three lines and execute. Let me wait for another few seconds so that students can copy down this. SciPy integrate import quad f equal to lambda x colon whatever the function is there, x raised to minus 2. I am writing as 1 by x square. Print, directly I am writing a quad integration. The function I am passing and the limits I am passing. The answer what I got is 0.75. So many other things are there. Just I want you people to go through. We may not discuss all these things. Just for your reference, we have double integration, triple integration, n-fold multiple integration is possible. Like that, many functions are there. Just see the function name and description, that's all. It may not be there in your syllabus. One should know which type of functions, what are different types of functions are available in the Python. When can I use? By seeing the function and description, hope you'll come to know, oh, these are the functions available in the Python, I can use it. I'll try to conclude the class today early so that you people can complete the assignment and submit today only, within a time, within a date, so that you will learn within the deadline how to work, because in industry also it is a must, within a deadline you have to complete the work. That habit you have to have. And these are the few more functions and their description. Take 1 more minute. A trapezoid rule, I think Simpson rules, all these things you have studied in your lower semesters. All those functions are available in the Python. We may not use, we may not discuss because those are not there in the syllabus. But one should know these are all possible in the Python. All functions are available. Whenever you want, you can use it. Just read. Some of the things you may not be knowing, don't worry. But remember, those functions are available. The meaning you may not be knowing, trapezoidal rule, somebody might have forgotten, no problem. Just remember, it's available. So I think we'll try to conclude today's class, and because you have to submit the assignment today before 5 p.m. Let me see how many of you will submit now. And I'll be here for another few minutes.